Hello and welcome to another video, this time going through question 1 from 2021, which happened to be a discrete random variables question, which recently they've started putting a couple of questions on but kind of mixing it up with other topics. So here we've kind of mixed up with sampling. So the question starts off with one disadvantage of using quota sampling over simple random sampling. Shame they didn't ask for the advantages, I think I'd almost rather prefer to answer that question. But yeah, you've got to remember with quota sampling and opportunity sampling, and they're not exactly the same thing. Opportunity sampling is like the worst kind of sampling. Well, I say worst, the easiest but also weakest kind of sampling you could do. Opportunity sampling is literally you sample anyone you have the opportunity to sample. Quota sampling is where you try and at least maintain like the correct proportions of the strata you're interested in from the original population by filling quotas, but you have to do that by asking people often on the street or something like that. Now, as a result of that, quota sampling is not random sampling. Quota sampling is not random, and so it introduces some bias. And so can introduce bias. Yeah, and what do I mean by bias here? And so can introduce bias. I mean basically that if you think of the actual real population, when you're doing simple random something from the real population, the idea is every single unit from the population has an equally likely chance of being selected. In quota sampling, that's not true. So you might decide that your quota is going to ask as many men as women, but it might be the case actually that in the population, maybe the population's, I don't know, my school sixth form, you wouldn't want, my school sixth form has probably like 20% men, 80% women, probably even more extreme than that, like because it's a girls' school, and so we don't have that many boys in the sixth form. And so, yeah, if you're going to introduce quota sampling and say I'm asking as many girls as boys, well, all of a sudden you've got, some kind of bias, because what I'm saying is that the population units aren't going to have an equally likely chance of being selected. So that would be the disadvantage. But yeah, so let's move on. Watch out for those sampling questions. Remember, quota sampling and opportunity sampling are not random sampling. All three of the other sampling methods are random sampling. So you've got simple random sampling, stratified random sampling, and what's the other one? What is the other one? Simple random sampling, stratified random sampling, and I'm missing one, and it's obvious, systematic random sampling. All of those three, and systematic doesn't sound very random, does it? But all of those three are in fact forms of random sampling. So anyway, let's get on with the question. That's enough sampling. Okay, in university, 8% of students are members of the university dance club. A random sample of 36 students is taken from the uni. Random variable x represents the number of these students who are members of the dance club. Right, using a suitable model for x, this sounds binomial to me because we've got a repeated number of trials. We're doing surveys. We're finding we're randomly sampling 36 people, and there's an 8% chance that each person goes dancing. Yeah, so this is definitely a binomial model. Okay, what are we going to have to do? We're going to have to find probability x equals 4. Well, that's binomial PDF because it's equals is the PD. Less than or equal to is CD on your calculator. Yeah, that's always the case. And so you're going to have to do that. Now, I've just realised I've started doing this video without a calculator anywhere nearby. I've already mentioned on other videos my calculator's been lent out. Oh, and there is one in here. Hang on, it's dark where I am. 1 second. I'm just going to go and get a calculator. Where is it? I'm sure there's one in here. Yeah, I found it. Now, I'm going to turn the light on as well so I can see what the calculator says. This is not an A-level calculator though, so... And actually it's not switching on. I don't even know why it's... Oh, no, has it switched on? 9 times, no, it's useless. For the next video I'll have to grab a calculator because I do actually like calculating through the questions, but I do have the values here. That should go to 0.167 if you do binomial PD with values n is 36, p is 0.08 and x is 4. And now here, because your calculator doesn't do greater than or equal to, it only does less than or equal to, you're going to have to think, what's the opposite of greater than or equal to 7? It's less than or equal to 6. So you need to do 1 minus the probability that x is less than or equal to 6. Use binomial CD on your calculator. And I think the final answer there is 0.703. Is that right? Is that what I just saw? No, it was on a different question, 0.0222. So there we go. Okay, so that's that done. Yeah. Okay, and let me just check, I've definitely got those yet, 0.0222. Okay, only 40% of the university dance club members can dance the tango. Okay, that's interesting. Now, these are people who are in the dance club, yeah? So it's 40% of the 8% of students who are in the university dance club. So find a probability that a student is a member of a university dance club and can dance a tango. Well, think of this as like a probability tree. Firstly, this is one way of thinking about it. They have to belong to the dance club, and yeah, they have to, it's only members who belong to the dance club who can dance the tango. You need to be 40% of that 8%. So can you see that's going to be a multiplication we need to do? Hopefully you can. So we're going to do 0.4 times 0.08, and that's 0.032, isn't it? Sorry, 0.032. Let me count the numbers of zeros correctly. Yeah, that looks right to me. Yeah, cool. A random sample of 50 students is taken from the university. Find the probability that fewer than 3 of these students are members of the university dance club and can dance the tango. Well, this is another binomial, isn't it? We've got 50 this time and 0.032. And so what we're going to do, if we want fewer than 3, is work out the probability that x is less than or equal to 2, because fewer than 3 means 2 or fewer. And then we're just going to use binomial CD to work that out. And that comes to... what does it come to? 0.78. That sounds really, really, really high. 0.7. Oh, fewer than 3 though. Yeah, it's almost likely. 0.785. There we go. And it's just a calculator job. So I don't think this question's particularly difficult. I was really interested in the disadvantage actually for the first one. You cannot reliably use it for inferences. Yeah, that's interesting. Look at what they don't allow. Not representative. I think that's quite harsh, but I suppose it isn't though, is it? Because quota sampling is representative. That's the idea behind quota sampling. So you can't say a disadvantage is that it's not representative when it is. But yeah, there's lots of, watch out for these. Yeah, any mention of non-response. You see, that seems quite harsh to me, because surely, I suppose with quota sampling though, unlike opportunity sampling, quota sampling, you can just keep going until you fill your quota, so non-response isn't really a problem, it just makes it slightly more tedious. But there we go. Anyway, that was question 1 from 2021. Okay, hope you enjoyed the video. Thanks for watching. Bye-bye.